So chapter 4 in the zyBooks text is on data types. There are a number of relatively short chapters, so we'll go through these relatively quickly. We'll start with this first one on constant variables. It seems kind of an oxymoron to say a constant variable. So we declare variables and we can set them equal to values. Sometimes there will be variables that we know will not change. And so we can mark those as constants when we declare them by using the word final. So we can say add the word final before their type. So we'll say things like final double or final int. Constants can have any name, but by tradition and coding practices, we generally use uppercase letters for their names. So they're all uppercase. And then we initialize them to some value. And the final means that we're not going to be changing that value later on. So things like, the constants, like the seconds per hour or miles per hour or stuff like that, the speed of sound, those are often used for constants. Some math constants like pi, it's better and more accurate to use that, and we'll see math constants in just a little bit, but these are generally for constants that aren't built into the language for us. So again, it just walks you through some of these exercises using the final to declare constants. And then there's a challenge activity you can do if you want. So that's the constants parts. So let's go on to these math methods and math constants. So there is a set of math methods you can use and constants. To use these, we have to do an import statement. We have to do an import java.language.math or java.lang.math actually. And once we have that, we have a set of math constants. Most of these are methods, what we call static methods, and we can just call them directly by saying math dot and then the method name. So for example, if there's a square root method, we can say math dot square root or sqrt. And then the one parameter here is the whatever number we're taking the square root of. So if we're putting in 49 here as the area squared, this will do the square root of this and return 7. And again, most of these math constants are methods that return a value, so we have to use them inside on the right side of an assignment statement or in a print statement or some other expression like that. So there's a wide range of math expressions you can use. A common one is the power function to raise some value to a power and do that. And similar to like spreadsheet functions, there are a lot of different ones for different things. So you can walk through these examples to see them. Here's a list of all the different math functions out there. So there's power, square root. Now some that you may not be familiar with are things like ceiling. This rounds a value up to the nearest integer. Floor will round a value down to the nearest integer. And then round is sort of more traditional round. So if it's 0.5 or above, it'll round it up. If it's less than 0.5, it'll round it down. There's a min and a max function. It'll compare two values and return either the largest or the smallest. The normal trig functions are here. That we have, and then some conversions functions. And we'll talk about this random one in an upcoming unit as we go. There are also two constants that we use frequently, particularly pi. They're not listed in this chapter, but if we just look up the math class in the Java documentation, it'll list pi, and it's capital P, capital I as the value of pi. It also lists e, which is again a natural log variable, and so both of those are declared. So you can just say math.pi or math.e to get at those constants. And so again, it's better to use that. It's more accurate than to declare your own version of pi as a final variable. So that kind of wraps up our math methods. Let's look a little bit at type conversions then. So we've talked a little bit about type conversions, especially integer division. We're going to talk about some other options there now that we do know about doubles. So we can run into issues when we're dividing numbers, especially when we're listing numeric constants, and then worrying about whether or not this is a double or an int or a double. So generally, if you do operations like a multiplication or a divide, if it's two doubles, you'll get a result that's a double. If it's an integer, you'll get a result that's integer, and if it's mixed, you'll get a double as a result for these. So we can look at some of these values and try to figure out, is the result of this going to be a floating point number or an integer, and then what are the values going to be returned. We do have to watch when we're doing division with integers. So here we have two integer variables. We're adding them together, so that's also an integer. So this will be an integer. And we're dividing, and then this is an integer also. So even though we're saving the result in a double, this operation is going to do integer division, and likely may not give us the results we want. We may want, when we often think of division, we're thinking about a decimal or a floating point value as a result. So we have to watch this, and we've got to sometimes cast this, tell the computer that this has to be a double. So there's something called a casting, type casting, where when you have an operation here, you can put a type in front of it. So I can write the word double in front of it, and that'll tell the computer that to convert this into a double here. So now even this, though adding two integers would result in an integer, we are casting it, typecasting it to a double. So that'll make this a double. And then we're dividing it and casting this to a double. So now we're doing floating point division here because we have two doubles divided by each other. So it talks about some of these common errors, and we have to watch when we're doing divisions and try to do casts to this. And again, it walks you through a simple challenge of activity that looks at this. If you want to try that out, you're welcome to.